This is Algebra 1, practice test 0. Let's begin. Write each as an algebraic expression. So I need to do 10 less than c. So whenever you have more than or less than, they're always reversed. So normally you would want to write 10 minus c in this case, because 10 and then c, but it's reversed because you have the less than. So this is going to be c minus 10. Again, less meaning a minus sign. There's no equal to sign because there's no word is. And over here, notice that we have the word is. That's going to turn into an equal sign. The quotient means you're going to divide, so you can either say b and 6, so you can say b divided by 6 like that, and that is 6, or you could have done b divided by 6 is equal to 6. Either of those would have been fine. And number 3, n cubed. So that's n to the power of 3. We have the word is, which is an equal to sign. So this is an equal to sign. And is less than. So sorry, I didn't read all of that. Is less than. And we don't have any equal to here, so we wouldn't have a line under here. And we have 43. Moving on to number 4. We're going to evaluate the expressions. So again, I see two negatives inside, so I'm going to make them kiss and become positive. This can be negative 6 plus 2. Notice that one of these is a plus, one of these is a minus. They're opposite signs, which means I'm going to subtract and do 6 minus 2. And I'm going to get a 4. I take the sign of the larger. This one is larger and the sign is negative, so I'm going to make this a negative 4. I'm going to drop the parentheses because I've evaluated everything inside the parentheses. I'm just going to drop this 8 divided by down here. It's going to be 8 divided by that. All right, notice that I have a positive divided by a negative. A positive divided by a negative is a negative, and an 8 divided by 4 is a 2. So the correct answer should be negative 2. Because I have some work here, I'm going to box my work in case my teacher thinks that this is the right answer. And number 5, I'm going to start with parentheses. Again, just making sure that you understand why I'm doing this. It's please excuse my dear Aunt Sally, where multiplication and division are at the same level and addition and subtraction are in the same level. Whenever you encounter multiplication and division, you just move left to right. All right, so in this case, I'm doing parentheses first. So what's inside the parentheses? Again, I have a double negative, so I'm going to make those kiss and become positive. Notice one of them is a minus, one of them is a plus. Those are opposite signs. You're going to subtract. 2 minus 1 is 1. Take the sign of the larger. The larger in this case is the positive, so this is going to be a positive 1. So there's no sign in between the 4 and the parentheses. So if there's no sign, you assume that it's going to be multiplication. So when I'm rewriting all of this stuff into the next step, I'm not going to just put 41. I'm going to put 4 times 1. So I have 1 plus 3 times negative 4, and the sign that goes right here is a times. Okay, so whenever we have multiplication here and multiplication here. I'm going to move left to right. So first I'm going to do this one, and then I'm going to do this one, although it doesn't really matter because there's no separation by a plus sign. So this is going to be, I'm going to drop down the 1. And now I'm going to do left one first. 3 times negative 4 is negative 12. Negative 12. And I still have a times 1. I'm going to just drop down this one. And now I can do this. Okay, I have multiplication before the subtraction. Multiplication before the subtraction. Negative 12 times 1 is negative 12, and I have 1 minus 12. And then from there, 1 minus 12 is negative 11 for my final answer, which I'll clearly box because I want to make sure that my teacher knows exactly where my answer is. And number 6, we have a bunch of parentheses. So the first inside set of parentheses, I have this 8 times 2, which we can say is 16. And I have 1 minus 5. If you're confused on how to do 1 minus 5, just remember that this is a minus sign, that's a plus sign, so you subtract 5 minus 1 is 4, take the sign of the larger, this is going to be a negative 4. And I'm going to drop down everything else. I have this negative 1 with a minus sign down here, so negative 1 with a minus sign. I'm going to drop down the division in between here and here, so I have divided by, and I'm going to multiply by negative 5. Okay, all the parentheses have not been dropped, though, because this set of parentheses still needs to remain. So I'm going to redraw that set of parentheses like so, which means I need to do all of you, and then I'll multiply by negative 5 at the very end. So what do I want to do first? No, yes, I want to do the division first. Division happens before subtraction. So first I'm going to say, what is negative 16 divided by negative 4? And it's a negative divided by negative, which is a positive. So it's a positive 4. 16 divided by 4 is 4. And then I'm going to copy down everything else. This needs to come down here. It's a positive 4, so it's a plus 4. So I have a negative 1 right here. And then I've done all that, so I just need to keep the parentheses. I haven't done everything in the parentheses, so that's why I keep them. This could be multiplied by negative 5 Keep evaluating inside the parentheses. Inside here, I have a positive 3. Again, I have opposite signs, positive and negative, so you subtract 4 minus 1 is 3. Keep the sign larger, it's going to be a positive 3. So I have a positive 3 times a negative 5. And finally, 3 times 5 is 15. Positive times a negative is a negative. You should be getting negative 15. If I make any mistakes throughout this video, please let me know and you get extra credit. I don't want to check my work because I want to go fast. All right, number 7, the square root of 43. 43 is a prime number. You cannot do any sort of square rooting, so the answer here is the square root of 43. Oh wait, so I thought I was reducing. I thought I was in geometry. I should read the instructions. Name the set or sets to which each number belongs. Okay, well, everything is real. So if you forgot to put an R in your answer, then you're wrong. What else is this? This is also irrational. So I am trying to remember. Irrational is, do we say that's an I? I don't remember the letter for irrational right now. My brain is not correctly working. I'm going to check the answer key on this one, number 7. It should be R and I think. Whoa, there's a lot of problems here. Let's see. Oh yeah, there's R and I got that one right. And I saw just a quick glimpse at that last question was negative 15, so we're getting those right. What about 0? I'm going through all the different letters, right? So first, is it whole numbers? There's the counting numbers. There's integers. So, okay, this one. So 0 is a whole number. It is not a natural number. Remember, natural numbers are things that were easily discovered. 0 wasn't easily to discover, so I'm going to come up here and say it's not a natural number. It is a whole number. It is an integer. Integer is a z. It is a rational because 0 is the same as the fraction 0 over 5 or something like that. So it's rational, and I believe rational is a q for quotient to do a division. And it is real as well. Everything is real. You always have to have the R. Again, I'm not super confident about these, so I'm going to make sure that I'm correcting my work here. If it was a positive 1, then I could have used a natural, but I think it's just WZQR. Let's check on number 8. WZQR. Okay, I even got the order right. Good job, Mr. Sindel. Oops, I hit the undo button. All right, what about number 6? Number 6 is basically the same thing as the last one. It's kind of like this whole number, but this one is a counting number, so I'm going to add the n in this case. So it's going to be, it is natural. Those are the first sets of numbers that humans discovered. It is a whole number. It is an integer. It is, what's the next one? Q for quotient, but it is a rational number. And finally, everything has to be a real number. If you forgot your R, you're doing something wrong. And number 10, it is not a natural number. It's not a normal counting number. Think of natural numbers as like counting sheep. You don't count 0 sheep. You just say, I have no sheep. 0 wasn't a number that you use. It's not a whole number. It's not even an integer. Integers are whole numbers and negatives, but it is a fraction. Fractions are quotients, right? So Q for quotient, and everything has to have an R. I'm pretty sure that those are correct. I'm not going to check the number 9 and 10. Number 11. I need to evaluate these expressions again. I'm adding fractions in this case. I have to have like denominators, and I do, so I don't have to do anything. And then I'm just going to make this minus sign and apply it up here. So I'm going to go ahead and put that minus sign and scroll that one out. So it's really a minus 5 plus 3. Opposite signs, one's a positive, one's a negative, so they're going to subtract. 5 minus 3 is 2. And I take the sign of the larger. The larger in this case is the 5, so this is going to be a negative 2 all over 7 for the final answer. All right, in number 12, I don't have like denominators, and I have mixed fractions, so that makes my life kind of tricky. First, I'm going to multiply 3 times 5 to get 15, 16, 17, 18. I have 18 fifths, and that's going to be, I'm going to put the plus sign up top, plus up here, and I need to make this something over 5, because right now it's technically over 1, so I'm going to multiply this one by 5, and multiply by 5. 5 times negative 4 is a negative 20. And 5 times 1 is 5. All right, now I have like denominators, and I can just add and subtract the tops. Negative 20 and 18 makes a negative 2. So I get negative 2 over 5 for my final answer. If there's any work that's been shown where it's not clear where your answer is, make sure that you're boxing your answers. And number 13, I do not have like denominators, so I'm going to multiply by the denominator of the other. There's an 8, so 8 and 8 is going to come up here and here, 8 and 8. And I have this 3, so I'm going to put that 3 over here and here, multiply by 3, multiply by 3. Let's see what we get. 8 times 1 is 8. I should write that. 8. 8 times 3 is 24. There's the minus sign, which I'm going to put up top. 3 times 3 is 9. And 8 times 3 is 24. Check it out. We have like denominators. We're ready to go. And 8 minus 9 is negative 1. So I get negative 1 over 24. In number 14, we're doing product. Again, just make sure that everything is not a mixed fraction. This is a mixed fraction, unfortunately. So 4 times 1 is 4. 5, 6, 7. It's going to be 7 over 4 times negative 1 over 5. And you just multiply straight through. So 7 times negative 1 is negative 7. And 4 times 5 is 20. So the final answer here is negative 7 over 20. And I'm always paying attention. Could those have been reduced? No. Could these have been reduced? No. There's no cross-canceling, and that means there's no reducing of the fraction that we could do. Over, in this case, the fractions are already ready to go. There's no mixed fractions. And check it out. 5 and 10 can both be reduced right now. They could be reduced at the end, but it's faster to do it now. I'm going to divide u by 5 and divide u by 5. That's going to turn into 1. That's going to turn into 2. So our real problem is negative 7 over 2 times 1 over 4. And that's going to be negative 7 over 8 for our final answer, which we'll then box. In number 16, it might be a little bit tricky, but remember that this is really negative 2 over 1. So I'm just going to multiply the tops. Remember this negative, I usually assume that it goes with the top. So it's a negative 2 times a negative 5, which is a positive 10. And 1 times 4 is 4. Ooh, I could have cross-canceled. I should have cross-canceled. Check it out. I could have done 2 and 4. What I should have done to go faster is divide by 2 and divide by 2. Because I forgot to do that, I have to reduce this fraction now. So let's go ahead and undo. I didn't divide by 2, and that's okay. You'll still get the right answer. I'm going to divide by 2 after the fact. When I do that, I get 5 over 2, and I get my final answer, which I'll then box. A lot of people will say, well, no, Mr. Sandell, that's actually 2 and 1/2 to make it a mixed fraction. That's helpful for bakers, but in math class, I like improper fractions because it makes our life easier. But yeah, so if you say 2 1/2, I will give you full points. I'm not taking off any points. On to the last page. This is the last page, yes. Okay. Last page. Whenever we have a division symbol and you see a fraction, the answer is always a keep, change, flip. So I'm going to keep the first fraction. Don't change it. I'm going to change the division into a multiplication, and I'm going to flip this number right here, which doesn't seem to be able to be flipped, but remember, it's really negative 2 over 1. Every number, if you just have a number, that number is always equal to that number over 1. So if I flip this fraction, it's the reciprocal, and it's going to be now 1 over negative 2. Doesn't matter that the negative's on the top or bottom. It doesn't matter as long as there's only one of them. Notice that we can do some cross-canceling here. So we can divide this by 2, divide this by 2, cross u to turn u into a negative 1, cross u to turn u into a 6. I'm not going to rewrite this. I'm just going to say, okay, 6 times 1 is now 6. And 7 times negative 1 is a negative 7. So my answer is negative 6/7. And I know that the answer key probably puts the negative out front as opposed to the bottom. It doesn't really matter as long as there's just one negative. In number 18, again, I want improper fractions instead of mixed fractions. So I'm going to do 10 times 3 is 30, plus 1 is 31. So I get 31 over 10. And I'm going to keep the division for now. I know that some people can skip this step and do a keep, change, flip at the same time. And then I'm going to do 1 times 8 is 8, plus 7 is 15. It's going to be 15 over 8. Don't forget your negative. That has to be dropped down. I'm going to put it in the top just for now. All right, we have division with fractions. So it's going to be keep, change, flip. So keep it, change it, flip it. And let's see if we can reduce this at all. I can divide u by 2 and u by 2. 31 is a prime number, so we can't really do anything with the 31. I was thinking 3 there for a sec, but no, I can't do anything. This is going to turn into a 4, and that's going to turn into a 5. And I think we're ready to just multiply straight through. These are big numbers. It's unfortunate, but we got to do it. All right. So what do we have here? When we do 31 times 4, here's how you do this in your head. Times 4 is the same thing as times 2 times 2, because times 2 times 2 is 4. So double is times 4. 31 doubled is 62. 62 doubled is 124. Okay, what about the bottom? Is there a trick? No, I'm just doing it in my head. 5 times 5 is 25. I'm holding 2 fingers up, but you can't see it. And then I'm going to do 5 times 1 is 5, 6, 7. and I get a 75. And don't forget that we did a positive times a negative, and that's going to be a negative. And because we did all of our reducing over here, I don't have to worry about, are there any common factors between 124 and 75? No, we already did it. And there it is, negative 124 over 75. Our final problem for this set is this problem, which I'm going to rewrite just a little bit. I'm going to say this is really the same thing as negative 10/7 divided by 1/9, because now I can clearly see, oh, embedded fractions, a fraction within a fraction, is really just a heap change flip. So if I keep it negative 10/7 and I change it and I flip this to 9 over 1, then I'm ready to multiply straight through. Can I divide anything? 10 and 1 can't be reduced. 7 and 9 are also co-prime, cannot be reduced. So this is going to be negative 90 over 7 to get my final answer. All right, last 3 questions. Here we go. Simplify each expression. So remember that when we distribute, that you distribute into each term. The terms are separated by the plus sign. So first I'm going to do 10n times 8n. First do the coefficients. The coefficients are that number out front of the variable. So 10 times negative 8 is negative 80. And how do we do the n's? So just as a reminder, this is n to the power of 1 and n to the power of 1. When you don't see a power, you assume that power is 1. And you just add the powers and leave the n. So this is n to the power of 1 plus 1 is 2, so you say n to the power of 2. Okay, that's the first start. Now I'm going to say, what's 10 times 10? That's going to be 100, and that plus sign is going to just drop down, plus 100. And again, now n to the power of 1, and there is no n, so you just leave the n to the power of 1. And a lot of students want to write n to the power of 1, but that's not reduced. You just write n if it is a power of 1, and we get our final answer. In number 21, you kind of do the same thing. You're going to distribute the 7. 7 times 3x is a 21. Just leave the x. And 7 times 10 is a positive 70. Don't forget you have to drop down this minus 7x. This is going to be a minus 7x. And now we need to add and subtract like terms, which is something that we'll review a little bit more in depth later. But 21x and negative 7x are like terms because they both have an x, and both those x's are to powers of 1s. So I can say 21 minus 7, just looking at their coefficients, is the same thing as 20 minus 8, I think. Minus 1, minus 1. I'm trying to think of a fancy way to do this. So here's what I'm trying to show you in my head. 21 minus 7. What I can do to both of these, I don't like subtracting 7 from 1, so that's really not fun. What I can do here is I can just subtract 1 and subtract 1. And this is going to turn into 20 and 6. So 20 minus 6 is the same answer as 21 minus 7. And 20 minus 6 is 14. And 14x plus 70. And there's our final answer, which will box. Last question. Here we go. Number 22. We're going to distribute. And be careful. When you distribute, you do distribute that negative out in front. So it's going to be negative 3 times 1 to get negative 3. And negative 3 times a negative 3m. A negative and a negative multiply to a positive. And 3 times 3 is 9. Leave the m. Be careful again, because this negative 9 is being distributed, not just the 9. Negative 9 times n is negative 9m. And negative times a negative is a positive. This is probably the most common mistake on this problem, is thinking, oh, I forgot to distribute that negative, and I only just left it out front. This negative is being multiplied by this negative as well to get a positive here. And 9 times 4 is a 36. From here, all we need to do is combine like terms, and we're done. Check it out. The m's, they're both m technically to the power of 1, but you don't need to write that. They kind of cancel each other out. If I have 9 melons and I get rid of 9 melons, I have 0 melons. And 0 melons is the same thing as anything times 0 is 0, which means cross them out. You just didn't have anything there. Your new problem is really negative 3 plus 36. And combining those like terms, those are like terms because they're just numbers. Negative 3 plus 36, one's a negative, one's a positive, so you subtract, take the sign larger, you get 33 for your final answer. All right, I might have made some mistakes. I was going fast. Thanks for watching this video, and I'll see you guys later.